Bismillahirrahmanirrahim. Now we are starting our 7th lecture, and this is part A of the 7th lecture. We finished with the double integration, and today we are starting the triple integration. So today's topic is triple integration. So when we talk about triple integration, it simply means we are talking about the volume. When we talk about double integration, it generally uses for calculating the area, the length and the width. There are two-dimensional areas. So generally when we use double integration means we are trying to calculate the area, and whenever we talk about triple integration, it means we are concerned with calculating with the volume. So it becomes easier for you if you understand all the basic ingredients of the double integration, then it will become much more easier for you to calculate with triple integration. And I am starting with simple examples of triple integration, and we do it in two ways. First, we directly write the integrals, and then in the second phase we will write the questions in word format. So you can understand how we will calculate the limits as you experienced previously in double integration, that the most important aspect of these integration, double and triple integration, is the understanding of the limits, that how limits will be calculated or how limits will be evaluated from the given question. So now I am starting with simple questions to show you. So this is question number 1. Let's we have an integral like this. This is triple integration, and we want to calculate this dx, dy and dz, where the given is that this is over r, and where r is defined in such a way that x is lying between 0 and 1, y is lying between 1 and 2, and z is lying between 2 and 3. So this is a simple question. You see that all x, y, z, all three elements have constant limits. So if all three limits are constant, means they are in numbers, no variable is involved in any of these, then it doesn't matter that you integrate with respect to x first or y first or z first. It will not create any problem, any change in the answer. So my advice that if I am doing in one way, please try to do it in other way. So you have the idea that there is no difference if we have constant limits. It will help you and give you practice as well. So let's say I am trying with respect to x first. So here the limits of, let's say we have the limits of x are 0 to 1, let's say 1 to 2 are limits of y, and 2 to 3 are limits of z. So let's say I am trying with respect to z first, then with respect to y, and let's say then with respect to x. So you can do it in either way. You can try with respect to x first or with respect to y first. It will not create any error or any modification in the answer when we try in this way. So if I integrate it with respect to x z first, it will be xz plus yz and plus z square by 2. Because with respect to z, we will treat x and y as constant. So then we need to substitute the values, which is 2 to 3, and then we have dy and dx. So integral of y is there, which is 1 to 2, and integral of x is there, which is 0 to 1. So it means when I substituted the upper limit, which is 3, so it will be 3x plus 3y and plus 9 by 2. Z square means 3 square 9 by 2. Then minus the lower limit was 2, so it will be 2x plus 2y and plus 2 square 4, 4 by 2 is 2. It means we have this term. This is dy dx and we have the integrals 1 to 2 and 0 to 1. Now if I simplify this one, 3x minus 2x will be x, then 3y minus 2y will be y, and then 9 by 2 minus 2, so 9 by 2 minus 2 means 5 by 2, so plus 5 by 2. So now this term will be integrated with respect to y. So here we have 1 to 2 and 0 to 1. So now integrating with respect to y. So let me write one more step here. So this is 0 to 1 and now I have this is xy plus y square by 2 and plus 5 by 2y and limits are 1 to 2 dx. Now we will substitute the limits of y. So it means first I substitute 2, so it means I have 2x, then plus 2 square by 2 means 2 and plus 5, because 5 by 2 into 2 is 5. This is upper limit, then minus the lower limit is 1, so x plus 1 by 2 and plus 5 by 2. This is the whole term and we need to integrate later on with respect to x. So now this is 2x minus x is x, 2 plus 5 7, so 7, and 1 by 2 plus 5 by 2 is 3, so 7 minus 3 is 4. So I just have x plus 4 dx and integral is from 0 to 1. Only x plus 4 we have. So now just integrating with respect to x, so x square by 2 plus 4x and substituting the limits 0 to 1. So this is 1 by 2 plus 4 plus 0 plus minus lower limit 0 plus 0. So this is simply equal to 9 by 2. So the answer is simple, 9 by 2. What I did, I integrated with respect to z, then with respect to y, and then with respect to x. So my advice is to please do it again and just try with respect to y first or with respect to x first, because what I am trying to convince you that once we have all the limits as constant, then it doesn't matter that which variable treated first and which variable treated second or which variable treated third. So now moving on to another example, we will make these examples difficult to learn the art of triple integration. So now I am moving on to example number 2. So in example number 2, we have again a triple integration x minus 2y plus z, let's say dx, dy and dz is there, x minus 2y plus z, and where R is the region given by, where R is defined as, so x is still defined as between 0 to 1, y is defined as between 0 to x square, y is defined between 0 to x square, and z is defined between 0 and x plus y. So this is the way in this example. So now you see that only the limit of x is given as constant. In limit of y you have one variable x, and limit of z you have two variables x and y. If in any limit you have two variables, it means it will be treated first. So in this example you need to treat z first, because in z you have two variables. In the limits of z you have two variables. So it will a clear indication that you need to integrate with respect to z first. So then on second stage you have only x and y left in the question. So it means my order will be 0 to 1, then 0 to x square, and then which I will try first, that is 0 to x plus y, x minus 2y plus z. We will try with respect to z first, then with respect to y, and then with respect to x. So now I am integrating with respect to z. So it means I have xz minus 2yz and plus z square by 2, and limits are 0 to x plus y. This is dy and this is dx. So this is what I did in integration. Now substituting the limits, upper limit minus lower limit. Since lower limit is 0, so all values will become 0. So substituting the upper limit, that is x and x plus y minus 2y, x plus y plus x plus y square by 2. And then minus lower limit, so 0, 0, 0. So I am not writing 0. So it means now we have 0 to x square and 0 to 1. We have dy and dx. Now there is no z in the question. So we have only two variables x and y, and two integrals are there. So now first we are simplifying this one. So I am simplifying the whole term here. So this is x square, then x into y, so plus xy, then minus 2xy, then minus plus minus 2y square, this is this one, then plus x square plus y square plus 2xy divided by 2. So it means x square xy minus 2xy is minus xy, then minus 2y square, and then we have plus x square plus y square plus 2xy upon 2. So if I take LCM as 2, so it means 2x square minus 2xy minus 4y square plus x square plus y square plus 2xy. So 2xy cancels with 2xy, and then we have 2x square plus x square as 3x square minus 4y square plus y square is minus 3y square divided by 2. So if I take 3 by 2, it will be x square minus y square. So it means if I simplify this one, because simplification makes your term much easier to integrate on second or third occasion. So you can do this simplification separately on a rough page. There is no need to incorporate this in the direct solution. You can do it here. There is no problem in doing it here. But it is better to do this in rough work. So if you have any mistake in it, you can accordingly correct. And then you have a clear and neat and clean solution here. So it means now I have the integral 0 to 1, 0 to x square, and here I have 3 by 2 x square minus y square dy dx. So it means I can write this constant outside, 3 by 2 integral 0 to 1, and integrating x square means x square y, and integrating y square means y cube by 3, and we need to substitute the limits 0 and x square, and finally the dx. So now it means now I have 3 by 2 integral from 0 to 1, and then again substituting the upper and lower limit. So upper limit is x square, so x square into x square minus 1 by 3, and in place of y cube if I write x square means whole cube and minus 0, so whole term will be 0, so this is dx. So if I simplify this one, this will be 3 by 2 integral 0 to 1, then I have x power 4 minus 1 by 3 x power 6 dx. Now it is in simplified form, so we can easily integrate this one. So if I integrate this one, this will be 3 by 2, and then I have x power 5 by 5 minus 1 by 3 x power 7 by 7, limits are 0 to 1. So now substituting limits, so this is 3 by 2, 1 by 5 means 1 power 5 minus 0 power 5 minus 1 by 21, 1 power 7 minus 0 power 7. So it means we finally have 3 by 2 here, and then we have 1 by 5 minus 1 by 21. So it simply means this is 3 by 2, and then I have 105 here, and 21 minus 5 is 16. I just make the LCM here, and it simply means I have 3 3s are 9 and 3 5s are 15, and then 2 8s are 16. So 8 over 35 will be the final answer. And there is no other alternative to do this question, as the limits are in variables, so you have to follow the exact order which is given here. And what indication I gave you, I am just repeating that one. What is that one? Look at these limits carefully. If in any variable you will find in limits other two variables, then it is a clear indication that you have to integrate with respect to this variable first. So this becomes the first integral, this becomes the second integral, and the constant becomes the third integral. So let's move on and do more examples in this context. So let's move on to have another example. This is example number 3 now. Because what is needed is to try different kinds of question to understand the whole idea or scenario. So let's move on to another example. Let's say I have integral like this, 0 to log 2 once we have 0 to log 2, then in second integral we have the limits 0 to x, and then in third integral we have 0 to x plus log y, and it means we have the term to integrate is e power x plus y plus z and dz, dy, dx. The question is directly given in this format. So if you look at the limits, it is a clear indication again that we need to integrate with respect to z first. Because in the limits of z there are x and y there, just like previous example, and then here we have x, so it means first we integrate with respect to z, then with respect to y, and finally with respect to x. So it means when I integrate with respect to z first, so it means e power x plus y will be constant and integral of e power z will become e power z, because we can easily write e power x into e power y into e power z. So with respect to z, e power x and e power y will be treated as constant. So these are the constant and limits are 0 to x plus log y, and then we have dy and dx. So now substituting the limits, so this is 0 to log 2, 0 to x, e power x plus y, and now I am substituting the upper and lower limits. So once we have upper limit, so e power x plus log y minus e power 0, we substituted the upper and lower limit as well. So now we will simplify it. So this is 0 to log 2, 0 to x. What we have now, we have e power x plus y outside, and inside we have e power x into e power log y. If I separate both these, and e power 0 means 1, so e power x plus y into e power x, e power log y is just y minus 1. So it means if I multiply this one, so e power x multiplied with e power 2x, it will be better if I show you that this is e power y and this is e power x. So e power x into e power x, e power 2x, then e power y and y. This will be the first term, and then we have e power x into e power y will be the second term. So here I am writing e power 2x into e power y into y minus e power x into e power y, and now we will integrate with respect to y, keeping x as constant. So this is 0 to log 2, and then e power 2x is constant, and now we are integrating e power y into y. So it is important to understand this step. It is very important to understand this step. I will write it here. I need to integrate e power y into y. So e power y into y means I need to apply u into v. The formula of u into v. So integral of e power y into y with respect to y. So I am showing you this integration. So what we will do, we will treat u into integral of v. So I am treating this is u and this is v. So u into integral of v. So integral of e power y is e power y minus integral derivative of u is 1 and integral of v is v into dy. So it means I have y into e power y minus e power y. So this will be the integration of this term. So I am writing it here, y into e power y minus e power y. Then in second term, minus e power x is constant and e power y integral is e power y, and then limits are 0 to x and dx. So now substituting the limits, first I will substitute the upper limit. So 0 to log 2, this is e power 2x, and then I am substituting here the upper limit x. So x into e power x minus e power x, this is upper limit, minus lower limit. So I will substitute 0, so it will equal 0 minus e power 0. So this concludes this part. Then here minus e power x, and we need to substitute where value, so e power x minus e power 0 dx. you need to be careful in substituting the limits, because it will be difficult for you to locate your mistake if you made any mistake in substituting the limits, because many variables are there. So you need to be very vigilant and careful in substituting the limits. So now I am just writing all the terms. So this is, if I take, this is e power 2x, and then we have e power x into x minus e power x, then minus minus plus e power 0 is 1. Then here we have minus e power x into e power x is e power 2x minus minus plus e power x, and this is dx. Now we can simplify it further, or we can just do it as a requirement. So now if I write it in simplified form, so it means 0 to log 2, and then I have e power 2x into e power x is e power 3x into x, then minus e power 3x, and then plus 1 minus e power 2x and plus e power x. These are the terms dx. Now when we integrate, again what is required, that we need to apply u into v formula on this term. So again I am doing this here. So e power 3x into x dx means this is u into integral of v minus integral derivative of u into integral of v and dx. So it means x into e power 3x upon x minus 1 upon 3 and e power 3x upon 3. So it means the integral of this term will be x into e power 3x upon 3 minus e power 3x upon 9. 3 3s are 9. Then minus integral of e power minus 3x upon 3 plus integral of 1 is x, then minus e power 2x upon 2 and plus e power x. And now we have to substitute 0 to log 2. So now substituting these limits and simplifying the term. So for upper limit I have log 2 into e power 3 log 2, because x is equal to log 2 for upper limit upon 3 minus e power 3 log 2 upon 9 minus e power 3 into log 2 upon 3 plus log 2 minus e power 2 into log 2 upon 2 plus e power log 2. This is upper limit. Then we have the lower limit, so minus. So I am putting all this in one bracket. So this is the upper limit minus the lower limit. So lower limit is 0, so first term is 0 minus e power 0 upon 9 minus e power 0 upon 3 plus 0 minus e power 0 upon 2 plus e power 0. So we substituted the upper limit as well as the lower limit. So now just simplification, this is log 2 upon 3 e power 3 log 2. So I am showing you e power 3 into log 2 means e power log 2 cube. So e power, it means simply 2 cube, it means 8. We use the property of log, so move it in the power, and e log theta is theta. So it means 8. So it means I am writing here 8 in place of this. Similarly here minus 8 upon 9, it is also the same term. Here again minus 8 upon 3, then plus log 2 minus, this will be 2 to the 4, 2 square means 4, and then e power log 2 is 2. So this is the simplification of upper limit minus the lower limit. This is 0 minus 1 upon 9, this is minus 1 upon 3, this is 0, this is minus 1 upon 2 and plus 1. So it means we finally have what we have now. This is 8 upon 3, this is log 2. So if I take log 2 common, this will be 8 upon 3 plus 1. Then we have minus 8 upon 9 and minus 8 upon 3. So minus 8 upon 9 minus 8 upon 3 means 9 is the LCM. So minus 8 minus 24 means minus 32 upon 9. So it means addition of both terms is minus 32 upon 9. Then minus 4 plus 2 is minus 2. Then inside minus, we have minus minus minus. So if I add both these terms, minus 1 over 9 minus 1 over 3. So 9 is a minus 1 minus 3. So it means minus 4 over 9. So it means minus 4 over 9. 1 minus half is plus half. So now moving on to last few steps here. I am just showing you all the calculation. So it means log 2 and 8 upon 3 plus 1 is 11 upon 3. Then minus 32 upon 9 minus 2. So this will be minus 9 to the 18 minus 50 over 9. Minus 32 minus 18. Then minus, and then we have minus 1 by 4. So 9 to the 18 minus 8 plus 9. 2 9s, 9 to the 18, 2 4s are 8, 2 9s are 9 1s are 9. So plus 9 minus 8, 1 upon 18. It means now we have only two numbers to be added. So this is equal to 11 by 3 log 2 minus, it means now I have 18 here, so minus 900 minus 101. So this is 11 by 3 minus 8 upon 3 log 2 minus, what will be the final answer of this one if we have in this form? This will be, if I add both these 18, 2 52 is 100. I hope that I made these all correct. So this will be the final answer of this term. Please do check the addition and subtraction of these numbers. Maybe it is possible that I made any error. If I made any error, please do correct in this form. So this concludes the first part of 7th lecture, and inshallah we will continue with these kinds of examples in the next part as well. So it's goodbye now.